Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zaya Shabi Omar and my matrix number is DE190194. I will present open loop position control for activity 1. D is the block diagram and key in all the parameter value, which is VA is 220, IM is 0.222 kgm square, BM is 0.003 meter second, RA is 11.2 ohm, IA is 0.121 H, and N is which is 1500 RPM. The KP is 0.61111. To check the block diagram is function. Key in the input angle, which is 1, and actuator is 1. Then we get input voltage 0.6111 and shaft motor position 11.73. Then we increase for the increase step by step value from input angle 0 till 10 and set the actuator gain remain 0. For the input angle 0, the input voltage 0 and the shaft motor position is 0. For input angle 1, the input voltage is 0.6111, shaft motor position is 0. For the input angle 2, the input voltage 1.222 and shaft motor position is 0. For input angle 3, the input voltage is 1.833 and shaft motor position is 0. For the input angle 4, the input voltage is 2.444 and shaft motor position is 0. For the input angle 5, the input voltage 3.056 and the shaft motor position is 0. And then we change the input angle, which is 6. The input voltage is 3.667 and the shaft motor remain 0. Position remain 0. For the input angle 7, the input voltage is 4.278 and shaft motor position is 0. For the input angle 8, the input voltage 4.889 and shaft motor position is 0. For the input angle 9, the input voltage is 5.5 and shaft motor position is 0. For input angle 10, the input voltage is 6.111 and shaft motor position is 0. Then for the increase step by step value of actuator gain from 0 till 10 and input angle remains 0. The result for 0 till 10, actuator gain is input voltage remains 0 and the shaft motor position is 0. The display is remain 0 because is no voltage input, which is 0, the voltage input. So this is the running. After that, continue to set the input angle, which is 5, 10, 360 for the potentiometer clockwise and anti-clockwise. For the clockwise, input angle 5 and actuator gain 1, the input voltage is 3.056 and the shaft motor position is 58.65. For the anti-clockwise, for input angle -5 and actuator gain 1, the input voltage is -3.056 and shaft motor position is -58.64. For the clockwise, for input angle 10 and actuator gain 5, the input voltage is 6.1111 and shaft motor position is 586.4. And then for the anti-clockwise, the input angle is -4 and actuator gain is 5. The input voltage is -6.1111 and shaft motor position is -586.4. And then we do the clockwise for input angle 360 and the actuator gain is 8. The input voltage is 220 and shaft motor position is 3.378 times 10 power of 4. And the anti-clockwise for input angle negative 360 and actuator gain is 8. The input voltage is negative 220 and shaft motor position is negative 3.378 times 10 power of 4. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Hasib Adinan. My number is DE190100. Okay, I will conduct this simulation for the closed loop position control. Okay, firstly, this is how the circuit for the position control. Okay, the input angle here, I have already insert the parameter given into the circuit. This is the potentiometer input sensor, same as the potentiometer output sensor, alternator gain, and here the mechanical and electrical part, and this is the display of the shaft motor position. Okay, if I run this, I set the input angle 0, and the alternator gain I increase from 0 to 10. The shaft motor position will be 0 also. Meanwhile, if I input angle I set to 0 until 10, then alternator gain I set to 0. The shaft motor position also 0. So we can conclude here the shaft motor position will be changed if will be no change if either these two in 0. Okay, for next activity, here is the input angle of 5, and for the given parameter we have to set 5, 15 and 360 input angle in clockwise and anti-clockwise. Okay, firstly here I use 5 input angle of 5 and alternator gain is 1. So after I already run this simulation. Okay, so I get the input voltage 3.056 and the shaft motor position 3.927. Then the output voltage 2.4. Okay. Then I do for negative 5, which is anti-clockwise. Same alternator gain. Then I get same value as clockwise, but in a negative way. Okay, then for 150 degree in clockwise position, I get input voltage of 91.67, shaft motor position is 138.1, and the output voltage is 84.37. I use the alternator gain is 5. Okay, then for the anti-clockwise of 150, which is negative 150, I get same value but in negative all same but negative. Then for the clockwise of 360 degree, I get the input voltage is 220 volt, which is the rated voltage, and the shaft motor position is 314.8, and the output voltage is 192.4. Okay, then for the in anti-clockwise 360, negative 360, I get same value but in the negative. Okay, that's all from me. Thank you.
My name is Mawar Akil bin Amran and my matrix number is CE210236. I will explain about the conclusion for this activity. We think the most effective method for doing some control system which is by closed position control system, because in closed position there is some parameter that send the feedback through the whole system. So even though there are some disturbance to the operation, there will be less effort to the all whole component to operating. I think that's all from us. Thank you.